to start a unit today that's not very mathy. And you guys probably figured that out in your homework, right? When we did homework and answering those 18 questions on the Gallup poll. Let's kind of just, most of you have turned it in, or if you still have it, that's fine. But name one thing that you learned when you did this article review on the Gallup poll. What did you read about? They stalked people. All right. How long has the Gallup poll been around? Since the 30s. A long time. Okay. Longer than I've been alive. Ha ha ha. Okay. Definitely longer than you've been alive. They've been around for a while. Give me something else that you learned. They have changed their methods. Give me one thing specifically that they learned that they only have to ask how many people? 1,000. And so that sample size is something that they figured out that you can, it's an important thing to worry about. But they said that once you ask more than 1,000, what happens? It's not cost effective because it doesn't change the accuracy of your results, right? So that's something that they discovered. So that's something that they, with trial and error, figured out. But it brings up a good point, and sample size is something, when we have a data collection process, that is something we always have to look at, okay? And so that's something we will address from here on out, really. And any kind of data collection process is sample size. Give me something else you learned about. What do they have to do? Or how did they start? Okay, so one big word or one big key idea that you saw coming up was the whole idea of the random selection. They use a process that's random, randomization. And that is, and we're going to see this in a few minutes, those are the two real key ideas when it comes to data collection, is that you have to make sure that you're introducing randomization, and that sample size has to be a part of the dialogue. How did the Gallup poll start? How'd they start asking questions? What'd they do? Door to door, right? Came and knocked on your door. If one more person knocks on my door and asks me to vote for somebody, I'm going to slam it in their face or make my dog get off the leash or something. I don't know. I'm just tired of people knocking on my door, James. Make them go away. What do they do now? They call you, okay? And calling can introduce some bias, and we're going to talk about what that is and what kinds of bias. So I've asked you guys to fold your pieces of paper or divide your paper into 6 sections. And the front section is going to be a data collection. These are different methods for data collection, so you can title it data collection if you want. And on the back side, we're going to talk about 5 different sources of bias. So you'll have one of these sections blank, but you have 6 on the front and 5 on the back that we're going to do. So we're going to start by talking about data collection. It is chapter 11. Remember, our book changed. Used to be chapter 12, but it is chapter 11, okay? And so far, and by the way, there's a lot of writing on these slides. I've already uploaded the notes to Fusion. Do not try to copy everything down that's up here. I will highlight what's important to put on in your little sections on your paper. Fair enough? The front page is data collection, and the back side is bias. Okay? Data collection methods is the front, bias is on the back. Okay? So, one thing that I want to address here is when we collect information from people, or we're trying to collect data from a population, sometimes it's not possible to ask everybody in a population. So we need a good sample of that population to do so, okay? So that's kind of where we're at, and that's really what statistics is about. Why do we do a sample survey as opposed to asking everybody in a population? Very few times can we ask everybody in a population. Why not survey everyone? Why can't we? Okay, there's going to be some sources of bias where maybe they won't respond, but let's be a little bit more specific. Why is it just not possible to ask everybody? Time, how time consuming it would be, money, cost, yeah. So those are the 2 big ones. So often time and money are reasons why we can't ask everybody. So we do have to ask a sample, okay? And we know the difference between a population and a sample, right? Population is everybody, sample is who we select from it. Bias is things that can go wrong, and we're going to address bias in a few minutes, okay? We already talked about how randomizing and sample size is important. Real quick, let's go back to bias. On your bias side, if you would, of your notes, I want you to do me a favor, okay? At the very top, and this is pretty important, please write these two sentences, okay? Top, bottom doesn't, remember how I said there's only 5 sources of bias? So just pick one of the empty boxes, the leftover boxes, to write this information. It can be fine, doesn't matter where. There's no way to fix a sample if it's already biased. That's pretty important information. So we're going to talk about what those sources of biases are in a few minutes. But if you collect a sample and it does have bias in it, there's no way to fix it. And I say that because it's going to come up sometime later this quarter at a quiz, a test, or something like that. Some people might suggest that if I ask everybody in a sample and it does have bias, as long as I just ask more people, then that bias will go away. But actually, if the sample is biased and I increase the sample size, all I'm doing is making that bias make it bigger. I'm magnifying that bias. So that's pretty important stuff, okay? What do I do if I have a biased sample? What am I going to do? I'm going to throw it away. Yeah, basketball wasn't my forte. But yeah, I'm going to throw it away, okay? I can't use it. There's nothing I can do from it if it's heavily biased. There is one thing that we can do to try to avoid bias, and the best way to avoid it is to collect your sample randomly, okay? And so that would be the second piece of information that you want to add there. Yes, okay? So the best way to avoid bias is to make sure that you're collecting your data at random, or you're collecting your sample at random, okay? Remember how from your Gallup poll article we said that randomness and sample size were key. And here's an example of why, okay? We're trying to make sure that our sample is not biased, okay? All right, so we'll come back to bias in a few minutes, but I want to spend the first half of class anyway talking about how to collect our data. And there's 6 different data collection methods, okay? So the first one is well, we'll come back to, actually, before we get to the types, I forgot about this part, so sorry. You don't have to write this down right now, but I just want to address some notation, okay? You'll hear me say things that are statistics, and we know them already. What's the symbol for a statistic for mean? X bar, okay? And the standard deviation symbol that we know? Just S, and the calculator puts a little X at the bottom, remember that? So I'm just going to write S, but it can be in terms of X or in terms of Y, depending. And then proportion, we haven't really talked about that symbol yet, but it's P with a little hat over it, okay? And we'll learn more about that when we get into it, testing, which is next semester. All statistics are based on samples, okay? So every statistic is based from a sample. We've collected a sample, we've calculated its average. We've collected a sample, we found its standard deviation. The new word that you may or may not have heard before is called a parameter. And a parameter is based on a population, okay? Our goal in statistics, in the course, or in the field of statistics, is to collect samples, analyze them, find some numbers, and hopefully if the sample is representative of the population, we can say things about it. That's the whole purpose of our course, okay? So there are some symbols for parameters that you need to know. And they are, the mean is something called mu, and these are all Greek letters. These are all Latin letters. These are letters that we use every day, right? X, P, S, whatever. These are Greek letters. This is pronounced mu, M-U. It looks like a U with a long tail on it. Yes, sir? You can put it wherever you want. If you don't know it automatically, you can also print them off at home. It's kind of up to you how you want to do it, okay? But you do need to know what the letters are. Standard deviation, the symbol for it is a circle with an O. It's pronounced sigma, okay? And if you notice, if you ever did 1-var stats on your calculator, remember how this symbol is right underneath this one? Okay, because you're given the parameter and you're also given the standard deviation for the sample. And then proportion is just a plain old P. Okay, it's pi. It's the capital Pi is a P. Lowercase pi is the symbol we're used to seeing. Okay, so these are just the symbols for those parameters. Again, parameter, population, sample, statistics. Just some notation purposes, really. So we're going to be looking at from a sample and different ways to collect samples. And the first way is called a census. So if you would, please write census in your, I guess, first data collection square. So it's the first kind. What is a census? Be more specific. How many people in what? In the entire population. So a true census is when every single person in a population is collected. So data is collected, excuse me, on every person or thing in a population. Doesn't always have to be person. So I'll say every one, maybe we'll say that, every one in a population. It doesn't have to be a person. It could be dogs, I don't know. It could be something else. How often, or when is a census a reasonable data collection method? When do you want to use it? To compare? To compare to what? Because you're collecting everybody in a population, so who are you comparing it to? So, okay, so you're talking about the United States Census, and you're talking about, so that's a little bit of a different situation. So every 10 years, the United States does a census. We'll come back to my original question in a minute. I'll kind of figure out or finish what you're saying. And they compare data from census to census. That is true. How reasonable is the United States Census? Say it louder. They try to, actually. They do. And part of the Census Bureau is to go out and try to find people that are undocumented. So yes, they try. But I think what you're saying is that's difficult to do, right? So it's difficult to count everybody. But they do their best. They honestly do. But it's not a true census in that word, because there are going to be people that aren't found, right? I agree with you. But let's go back to my question. How reasonable is the United States Census? One, not 100% accurate because of everyone that's not counted, but what going to be some other issues with it? What are some issues with it? Okay, every 10 years, so time. It costs a load of money, right? But the United States finds it valuable, and so they feel like we can afford this kind of money, okay? But not every country does that, and it's not a true census. But a census doesn't have to be the United States one. It can be just, for example, our NFL salaries that we're going to get back to after the break, by the way, because we're going to redo our graphs, and we're going to do something different starting. We're going to save this one and redo it in a different way starting next week. But if I wanted to do a census of NFL salaries, could it be done? Because I have every single salary for NFL in 2009, don't I? I have that information. So I can do a census. So when is a census a reasonable thing to do? Yes, Anna. When the population is small, right? So it's reasonable when the population is small. Because then we have enough time and we have enough resources, money and otherwise, to be able to ask or collect all the information we need. Often a census is not possible because it's just too big or too much money or what have you. So it's not something that's often done. Okay? Because too much money, too much time. Would you agree? Okay. So census is the first type of data collection, and it's probably the least often done because it's just too hard. But the important question is who is the population of interest? Who are we caring about? What is the information? Who is the information we want to collect on? And so we'll kind of address that as we go through. The second type of data collection method has an abbreviation, and I will often use the abbreviation SRS to mean a simple random sample. Okay, so this is number 2. This is the second type of data collection method, number 2, and it is a simple random sample, SRS. Make sure you know that SRS because that is something that I will use and I will say over and over. It is the gold star data collection method, okay? It is what we want to be able to do an SRS. And I have an example of an SRS that we can use. An example of an SRS would be Vietnam, okay, and the draft. Some of you have studied that maybe in the past or are currently studying that. I'm not sure where you are in your history studies, but the Vietnam draft in the 60s and early 70s was where every male ages, I think it was 18 to 28, and they had a draft card, right? And so they would call numbers. And so every person or every male in that age range was assigned a number, and they were randomly picked out. So that's how that simple random sample became. Okay? But there were some issues with that, and we'll talk about the biases in a few minutes. Okay? So what's important, and I have a whole lot written here, and I don't want you to write it all. Okay? So let me highlight the key points. We want every possible sample of the same size will have an equal chance to be selected. When you have an SRS, that is going to hold true. If I make my sample size 5, and let's use the NFL salaries for example, and I have my bucket of sticks, and that is the population, that is every NFL football player in 2009 in that bucket, and I want to grab 5. I put my hand in there, and I grab 5, and then I count them, and I put them back, and then I grab another 5. Will each of those have an equally likely chance, will each group of 5 have an equally likely chance of being selected? No, unless I do something important. Let me demonstrate what I'm showing you with the box. So I have my box, and I'm going to grab 5. I'm going to put 5 in, and I'm going to grab 5. And I'm going to put 5 in, and I'm going to grab 5. Does each group of 5 have an equal chance of being selected? Why not with what I'm doing right now? I'm not mixing them up. And believe it or not, back in the era of the Vietnam War, that was an issue. Because if you studied the history, you would know that when the draft first started, entire towns of men ages 18 to 28 were being drafted at the same time. It's kind of like if you lived in Manassas and Zachary's card came up and you were a man aged 18 to 28, you knew you were doomed. Why do you think that was? They had to change it, and they did change it. But why do you think that was? They didn't mix it up. They had, literally, they had these big barrels, and everyone put their draft cards in them, but it was like the town mayor of Manassas came and put all his in, and Fairfax, well, but Manassas would be at the top. Like Fairfax would put theirs in, I don't know, whatever the town, Herndon, whatever, okay? And then Manassas would be at the top, and so they would just pick from the top. And guess what? Everybody from Manassas got called, okay? So what did they have to do to fix that problem? They actually ended up taking these bins and putting them on a big roller and rolled them around to mix up the cards. And that's important. It's kind of like the lottery. You got to mix up the numbers, don't you? Okay, same idea. So an SRS, an important thing about an SRS, in order for it to truly be random, what do you have to do? If you're going to put everything in a hat, you got to mix it up. If you're going to put everything in a hat and you're going to use that example or a bowl or a whatever, a bin, and you're going to pull them out, you have to make sure you mix them up. Oftentimes, at least now, we use computers and we use random number generators, and so we don't have to worry about the idea of mixing them up. But you do want to make sure that everybody has an equally likely chance. An SRS is the standard by which we measure all other sampling methods. Remember how I said that an SRS is the gold star, right? It's what we want. It's what we aim to be. Because truly, it's random. And doesn't randomization, isn't that key to reducing bias? That's what we want, isn't it? Our bias is going to be reduced if we introduce that idea of randomness. So an SRS is truly random. Here's an example of an SRS. I want to ask my students a question about what they're going to be for Halloween. Okay? Just asking. But I know that I teach too many students. I really don't, but let's say I did. Okay? And I wanted to gather a sample. I wanted to do an SRS. How would I do it? How could I get an SRS of my students? Well, I could assign each of you a number, and I could use my calculator, and let's say I had 50 students, and each one of you get a number, and I go to my calculator and I say, give me random integer from 0, 1 to 50, and press enter. And look, lo and behold, 34 comes up. Boris, you win. What do you mean for Halloween? Yourself? Yep, okay, that's good. All right. My daughter's going as mustard, and her best friend's going as ketchup, and my dog is going as a hot dog. And then the next friend is French fries, I think, and the next friend's a hamburger. So they're all like going as a group, and they're all themed. Is that a thing that 11-year-olds do? I don't know. Apparently, it's a thing my 11-year-old does. Whatever. Okay. I'm just going to be the lady say, candy? Candy. Okay. Anyway, clear on what an SRS is, and how to generate one if you needed to, because you're going to in a few minutes. All right, third one is a stratified random sample. Third one. So it's not a simple random sample, that's an SRS. But a stratified random sample is still a very fair way to sample. Okay? An important part about a stratified random sample is that you are going to divide them into homogeneous groups, and sometimes they're called strata. Hence why it's a stratified random. You're going to take your population and you're going to break them into homogeneous groups. What does it mean to be a homogeneous group? Everyone in the group is what? Alike or different? They are alike. So you want to divide your population into groups that are alike. Often we talk about grouping males and females together because males are more alike than females are more alike. Sometimes we'll group old people and young people together or group by age. I can think of a way to do Stonewall Jackson High School students. I can group you in strata by grade, 9th graders, 10th graders, 11th graders, and 12th graders. Okay? So the idea of a stratified random sample is you first break them into homogeneous groups. Then you use a simple random sample within each of those strata. Okay? So you divide them into groups, and they have to be homogeneous now, because we're going to look at one where they're heterogeneous, so we have to be careful. So we have homogeneous groups, and then we randomize within those groups. So if I wanted to talk about students at Stonewall Jackson High School, and I wanted to make sure that my sample was representative of all the students at Stonewall Jackson High School, I could break them into strata, freshman, sophomore, junior, senior, and randomize all the seniors and pick so many seniors, pick so many juniors, sophomores, and freshmen. That would guarantee what? What? No, it would guarantee that each group would be represented. I'd at least have some of each class to be in my sample, right? What if I did an SRS with students? Could I guarantee I would have freshmen in my group? Can't guarantee. So if I knew I wanted to make sure it was representative, do you see why this sometimes is a better way to do it? You want to guarantee that you have everybody is represented. Okay, good. The next one is called a cluster sample. Let me just make sure I didn't miss anything down here. Oh, yeah, sorry, one thing. Add that to your stratified. Stratified random samples can reduce bias. That's pretty important. One, because you're putting like people together or like things together. You're creating those homogeneous groups, and you are randomizing within those. Stratifying will also reduce the variability of your results. Because the people in each group are alike, their responses shouldn't have any other lurking variables that are swaying their answers. You're putting them alike together for a reason. Think about gun control as an example. It's a big issue right now with the voting coming up on Tuesday. Why do you think, if I was interested in people's opinion on gun control, why do you think using a stratified random sample would be important? How would I stratify it? Well, you've already gathered your answer. I don't know who's for and who's against it, okay? So I got to stratify before I know the results of my survey. Age might be a factor. That would be one way. Why do you think age would be a factor or an issue? Okay, but what if I'm talking about just voters? Do you think young people would answer they have a different opinion on gun control than older people would? Okay, probably. Who else? Well, give me some other groups that might have a different opinion. Gender. Okay, I think that's a big one. Typically, women feel very strongly for gun control, and men typically feel against it. That's just kind of, I'm totally generalizing here, okay? Totally generalizing. But I'm just saying that is typically something you want to, gender would be something you would want to stratify for. Okay, good. All right, are we on the third one or fourth one? Fourth, okay. Cluster sampling is our fourth. Now, this is important because people get stratified random sample and cluster sample mixed up. Okay? So, the difference about cluster sample is that you are splitting into groups, but these groups are not alike. These are heterogeneous groups. Okay? So, we're splitting the population into clusters, but they're not necessarily homogeneous. Okay, they would be probably heterogeneous. We are not purposely putting the males in one group and the females in another. That's stratifying. An example of cluster sampling would be this. And maybe we'll write, you can write this example down if you want. If I'm interested in the opinions of people at Prince William County schools, or let's even be more specific, I'm interested in students, high school students in Prince William County. Okay? If I wanted to do a stratified random sample, I would do 9th, 10th, 11th, to 12th graders across the county. Would you agree? I've stratified by age or by grade level. I don't want to stratify. I want to do a cluster sample. What I would do is I would randomly pick an entire high school. I'd randomly pick Stonewall Jackson High School, and I would survey everybody at that high school. So a cluster sample is when you randomly pick one cluster and then you perform a census within them. So if I'm interested in interested in Prince William County schools, I would randomly pick, I'd number all the high schools, I'd put Patriot 1, Stonewall 2, OP 3, Battlefield 4, Colgan 5, I don't know, there's 12 of them, right? Well, 12 next year, there's 11 right now. Okay? Huh? Colgan High School is opening next fall. Not yet, but it's probably not filled up yet, but it's coming, I think. Okay, yes. Anyway, my point is I would number them, and then I would randomly use my random calculator generator to pick the one high school, and I'd just do a census of that whole high school. Okay? Notice what it says down here. It's important. Cluster is not the same thing as stratified sampling. They are different. When you stratify, what are you putting into, what kind of groups are they? Homogeneous. They are like groups, because you are worried that because of whatever factor, the gender, the reason you're separating them, is going to affect their answer. Okay? We stratify to ensure our sample represents the different groups. Strata are homogeneous. Okay? Clusters are more or less alike. Each of them are heterogeneous. Each cluster represents or resembles an entire population. That's important. In a cluster sample, the cluster itself is representative of the entire population. The whole goal for sampling is that our sample should represent everyone. Okay? Not necessarily if we randomly picked the cluster. In that school. Because Stonewall is representative. Well, what do you think? Do you think Stonewall is representative of all high schools in the county? I mean, I agree with you. Okay, I agree, and that's part of what you're saying here is that sometimes the clusters themselves aren't necessarily representative. So I agree. I don't think that this is the best way to sample. Okay. Which one, if you had to pick one, which one do you think would be the better one to do? Well, SRS or the stratified, right? Because that's really going to make sure that you're randomizing within the strata. Cluster sampling sometimes is just convenient, okay? It just happens to work out that way. Pardon me? And it's affordable. Does it say that? Oh, yeah. Because it's practical and affordable. It says it right here. Yeah, right. And so this is really the reason why we do a cluster sample. Okay? But I agree with you. I don't think that it's the best way, Angelica. I agree. Okay? All right, on to our fifth one. A lot of writing today. It's not math. I feel like we're in English class or IB Psych or something like that. All right. The last one, we're on 5, 6? Maybe there's only 5. You never know. I think there's only 5. Yeah, I think there is. The last one is multi-stage sampling. Okay? Oh, no, there is 6. There is 6. I apologize. Multi-stage. Hang on, let me go make sure. Real quick. Did I skip one down here? Sorry. No? Okay, it must be. There it is. Okay, yep. There's 6. I lied. Multi-stage is when you do more than one type of sampling at a time. We use a variety of sampling methods together. Okay? So let me give you an example. let's say I'm interested in students at Stonewall Jackson High School. I number all the high schools and I randomly pick one and I get Stonewall. Rather than do an entire census of that cluster, I'm now going to randomize within that, and I'm going to do an SRS inside. And I'm just going to pick a few students to talk to within that cluster. Okay? That's multi-stage because I'm doing two things at once. I chose the cluster, now I'm going to randomize within it. So it's multi-stage. Okay? So, sampling schemes that contain several methods. A variety of sampling methods together, more than one. Okay? All right. This last one is 6. It's our 6th method of sampling, and it's called, what, baby? It's all going to be online. Okay? The last one is called systematic sampling. And systematic sampling is okay. Okay? But there can be a problem with it. I'm going to cover it up so you don't get to see everything. So this is important. An example of systematic sampling is taking every 10th person on a list after I put them in alphabetical order. Okay? So this is just an example of a systematic sample. Okay? What's the problem with it? Where's the randomness introduced? If I know I'm going to pick every 10th person, Jenny is never going to get picked. Why? Because her last name begins with an A. Poor Jenny. She's not my 10th person. But that's not fair because every person doesn't have an equally likely chance of being selected. Do you agree? So how do I fix that and truly make this sample a systematic sample? In order for it to be effective, you have to randomly pick where you start. Maybe you don't start with the A's. Maybe I start with the Z's or the R's or the Q's or whatever. So as long as you randomize the starting place, then you can go every 10th person. If you have an alphabetical list, and I've numbered them, I'm going to pick a number randomly on my calculator and tell me where to start. I'm going to start at the 53rd person. Okay? That's my starting point, and then every 10th person from there would be a systematic sample. Does that make sense? Okay. Good. The systematic sample is only okay to use when you think that the order of the list makes no difference. Just because Jenny's last name begins with A doesn't necessarily mean that she's going to have a different opinion than me, who has a last name that begins with M. Our last names have nothing to do with it, right? So that's why a systematic sample would be okay. But let's talk about a different way and why this one might pose a problem. Why should we not use a simple random sample in this case? Fire drills. Okay? We're going to go outside and we're going to pluck every 10th person that comes out of the door off to the side, and you are going to be my sample. Why would that not be a way to do it? What's wrong with that methodology? Based on what I just said. How do we exit the building? As a group. So guess what? Everyone in Mrs. Mackert's class, because we're all together, means if Maria got picked, we're all clear. Bye, Maria. She's our guinea pig. See you later. Bye. Woohoo! We're free. That just means that my likelihood of getting selected is dependent on her, right? So we don't have an equally likely chance of being selected. So we have to be careful. Systematic sample is only okay as long as the order by which you're arranging them doesn't make any difference. Okay? In a fire drill, we all exit together, so that's going to make a difference. The last name doesn't make a difference, usually. I say usually because it could sometimes. Families have the same last name, so yes.
Every 10 person select 10 of those 10 people as that result. Does that like change what it is, or it's just this is just how you sample it?
This has nothing to do with the results themselves. This just has to do with the way that we're collecting, the process by which we're collecting the data. Yeah. The expectation, Byron, is that because if we do it randomly and we do it with one of the correct sampling methods, that we won't have any issues with the answers. Okay, that's the goal in mind anyway. Okay? All right, so I'm going to pause the recording here for a minute because we're going to take a little, we're going to do a little exercise. And so I'm going to pass this out and we're going to talk about it, but it is a classroom. I'll pause it once I'm done telling you what it's about. But we're looking at a preschool class, a preschool that has 12 classrooms, okay? If you've ever worked at a preschool, went to a preschool, has a little brother or sister that goes to preschool, you went to preschool, something, you know that preschool ages is between 2, 3, and 4 years of age. Once you get to be 5 years old, you go to kindergarten, right? So at this particular preschool, I have, you can go ahead and look at the chart that I've given you here, and you have 10 students in each of the classrooms. So I'm going to do my best to recreate this here. So read it as I go through. But we should have age 2, we have 4 classrooms. Age 3, we have 4 classrooms. And age 4, we have 4 classrooms. Do you agree? And how many are in each classroom? 10. I'm just going to write 10 in here, if that's all right, just so I know how many are in each. And so what I'm asking you to do, and you have 3 different ways to sample. So this is our population of interest, this particular preschool. And I've asked you in step 1 to explain how to conduct an SRS. So I want you to, and then step 2, how to do a stratified sample. Step 3, how to do a cluster sample. So I'm going to pause the recording, and I want you guys to talk to the people at your table, and let's decide how that can happen. Okay? So you go ahead and do that. So with a simple random sample, what are some things I'm going to do? So let's do an SRS first. How do I do an SRS in this situation? Not 1 through 20, 1 through 120, okay? Now, we have to be careful of whether it's just 1 to 120 or 001 to 120. So we're going to number all the children 001 to 120. Why do you think I'm using 001? Because if I'm going to use a table, which as you can imagine on a quiz or a test, that's the only way I can ensure that you know what you're doing, because the calculators can be different, right? Because we haven't seeded them yet. So I'm going to have you just use the same number of digits. Is that okay with you, Zachary? We're not done. Okay? An SRS means you've numbered the entire population. So I've numbered all 120 students. Now I'm going to use either my number table, or I'm going to use a calculator, either one. I'm going to use a table just because that's something you'll do on a quiz or a test, okay? So we're going to use a random number table and select how many students, Zachary? 30. We're going to select 30 numbers. That in of itself is still not enough. There's a couple of things I have to be careful of. Give me one issue that could come up. I can't reuse numbers. I have to ignore repeats. If I have already selected number 10, that person's already in my sample. I can't pick her again, right? So we have to ignore repeats. And this situation only arises when we're talking about a table. This is not an issue with the calculator. But what other numbers, if I'm looking at a table, am I going to have to ignore? 121 to 999. Aren't those three-digit numbers going to come up sometimes? So I have to ignore them. If I'm using a table, I only care about those numbers, right? So I'm going to also, if I'm using a table, ignore numbers 121 to 999. We'll just pass those on and go to the next three. Okay? Obviously, you're ignoring more than you're paying attention to, so a table might not be the best method here. A calculator would probably be the best, but I just wanted to make sure I pointed that out. Okay? How about number 2? I'm going to give you a pause again. I want you to think about option 2. How about a stratified sample? Okay? So tell me what you think. So I'll write it down here. Talk to the people at your table. What makes it a stratified random sample? Or how would that happen? What's the first step in a stratified random sample, Ricardo? Good. I'm going to divide them into strata, homogeneous groups. And in this case, those groups are going to be ages, right? We're going to look at all aged 2 kids together. We're going to look at all of aged 3 kids together and all of aged 4 kids together. I've now stratified them, correct? So we'll do that first. We're going to divide into age groups. Now what am I going to do? What's the next step? I'm going to number each kid in age group 0, 1 to 40. Perfect, because there are 40 in each age group. Do you agree? All right, so we're going to number each child 0, 1 to 40. Zero, 1 to 40. If you did 0, 0 to 99, whoa. Yes. Hang on a minute. She's exactly right. Well, this one's okay. We'd also have to ignore, not only this, wouldn't we also have to ignore 0, 0, 0 up here? I forgot about that one. Thank you. If you wanted to number them 0, 0 to 39, would that be okay? That's okay too. But don't forget about that first double 0. Thank you, Angelica. Excuse me. Okay, so I've numbered the children. Now what am I going to do? Select 10 from each group. Good. From each strata. Good. I agree. What am I going to have to ignore? Ignore repeats and 0, 0. Good. Make sure that you can read that. It's supposed to say 41 to 99. I agree. Perfect. That's going to guarantee that in my sample I have some 2-year-olds, some 3-year-olds, and some 4-year-olds, isn't it? Okay, it's going to make we're going to guarantee it's representative of that particular preschool. All right, the last one is your cluster. So I'm going to pause for a second. Many of you have already decided, but I want you to think about how we could do a cluster sample. Again, we want 30 kids. Okay, so how do we do? So here's a question that might be important. How many clusters do I have? I have 12. Why do I have 12 clusters? Because I have 12 classrooms. So each classroom is considered its own cluster. How many clusters am I going to have to pick? 3. Okay? So what am I going to start? I'm going to number what? Well, if I'm doing 0, 0, it'd be 0, 0 to 11, wouldn't it? Let's do 0, 1 to 12. Is that okay? So we're going to number each classroom 0, 1 to 12. And I'm going to randomly pick how many classrooms? 3. And what am I going to do with each of those classrooms that I pick? I'm going to survey everyone in. right? Because that's what a true cluster is when I do a census of each of those clusters. So then I'm going to survey everyone in the classroom. What am I going to have to ignore? Ignore repeats, because if I've already surveyed a whole class, I can't survey them again. They've already been asked. And I'm going to ignore numbers 0, 0, and 13 to 99 if I'm using a table. Okay? Obviously, if I use a calculator, it's not going to pick those numbers because they're not going to be chosen.
How did you get 3?
Because there's 10 in each room, and I want 30. So I got a total of 30. I just picked one classroom, and I've surveyed everybody, I've only selected 10 kids. I want a total of 30, so I've got to do 3 classrooms. Okay? Does this clarify the difference between the types of sampling a little bit better? Because you've got one situation, but there's 3 different ways we could have sampled from within that. Okay? All right, go ahead and turn your paper over. We're going to get into the bias part of it. Before we do, though, let me talk a little bit about some vocabulary. Who is the population of interest? Let's talk about the Vietnam example, okay? So in the draft, who is the population of interest? Males, ages 18, I think it's 28, I'm not sure, but I think so. Fact check me on that, okay? What is this idea of something called a sampling frame? A sampling frame is actually everybody you're going to be on the list, okay? So everybody that you actually are going to draw their draft card from. Think about Vietnam for a minute. Why is the sampling frame not the same as a population? Why is it a little bit smaller? Who could be excluded from this population and they wouldn't be drafted? Wasn't rich, but there were, why couldn't you get drafted if you were in Vietnam? If you had a medical reason why you couldn't be there, if you were disabled, so we'll say you could have what's called a medical release, maybe, there's a word for it, but there could be a medical reason why you couldn't be drafted. There's one more reason I could think of. Huh? Religion actually didn't come into play, believe it or not. I don't think you could, I don't know that 100%. Well, they protested the draft because of religion, but they didn't preclude them from being selected for the draft. They went to jail because of it. Yes? If you were the only male child in a family, I do believe you were exempt from being drafted as well. And there's one more. If you were in college. Did you know that? If you were in college, you actually got pushed back. You weren't drafted that particular year, you could be drafted the next year. So they weren't, if you were in college, so these were some, I'm sure there were others, I'm not a history major, I'm just giving you some examples. But these are some of the reasons why the sampling frame is not everybody in the population. Okay, there could be some reasons why you're exempt from it. Then we have the ideal sample, and then we have who we actually took. Okay? So just kind of, here's how we narrow the idea down of who we're going to get when we get our sample. But what can go wrong? Here's where you're going to, go ahead, question? It's just what's your ideal situation, and then who you actually get. Because you could ask some people some questions. So here's an example, okay? You draw someone's draft card, and so they're part of our target sample, but they're not in our actual sample because maybe they got hit by a bus. And so we got their draft card, they were picked, they're part of our target, but they're not in our actual sample because they already died. I'm being dramatic, but you get the idea, okay? So it's who we really want, and then there's going to be some extenuating circumstances why they're not actually in our sample, okay? All right, what's the bias? Turn it over. We got 5 things of bias we got to deal with. Today is a vocabulary day. I'm sorry, but it is, okay? So again, don't write everything. I'll highlight what's important. Voluntary response bias is what it's called, okay? And that's number 1. Voluntary response bias. Voluntary response bias is a type of bias that happens when people who have very strong opinions or are very strongly motivated reply to the survey. So voluntary response bias is a bias that exists when people who answer the survey are only people that have very strong opinions or who are strongly motivated. I have an example that I tend to use with this, and it's the restaurant example. Anybody ever go out to eat? Okay? So you ever had like some really bad service at a restaurant? Okay, I went to a new restaurant by my house recently, and they literally just opened, and my husband and I sat for 35 minutes before our appetizer came out. I thought to myself, y'all aren't coming back here. Where's that comment card? You know what I mean? So if you get upset, aren't you more likely to fill out that comment card that's sitting at your restaurant example, or your restaurant? You're going to say, how was your service? Terrible. How was your experience? Awful. Who are you? Terrible. Right? Rate from 0 to 4, 0, 0, 0. Okay? When you have a bad experience and you're very opinionated about that, aren't you more likely to respond? If you just have an okay experience, you know, the mussels were okay, you know. I ate mussels when I went to this restaurant, but they actually weren't okay. They were kind of terrible, but that's okay. If you just have an okay experience, are you likely to fill that out on the card? No. But if you have a fantastic experience, are you more likely to fill out the card? Probably. So the more extreme your experience is, the more likely you are to say something, okay? But if you're just okay in the middle, so it's a bias. So I'm going to say the restaurant example, and hopefully you know what I mean when I say that, okay? People who are strongly opinionated. Anyone have that friend that you decide where you're going to go because that's where they want to go? Okay, you want to go to the movies? Well, I want to see Martian. I don't really care what you want to see. Shut up. You know what I mean? Don't I get a say? Don't I get to like have a vote? What's wrong with you, Esmeralda? Everyone has that friend. You know who I'm talking about. You want to kick him in the I'm just saying, it happens, right? So that's voluntary response bias. The next time that your friend forces you to do something because it's what you want to do, all right, stop being stop performing that kind of bias. It's not fair to your friends, Jenny, okay? Got it. All right, number 2, convenience sample. A convenience sample is a kind of bias because it's not representative, okay? It's not representative. It may not be. It may be, but it's not necessarily. It's more than likely not. I sometimes refer to the man on the street. Anyone ever watch the news? Never? Ever in your life? You've never watched the news in your life? Do me a favor, turn it on. It's interesting, kind of fun to watch sometimes. Because, like, you ever see a reporter who's, like, on the side of the road, like a busy corner, and they're like, what do you think? And you're just like, what, dude, get out of my face. You know what I mean? Like, what? Because you're standing on the street corner, and so you're going to say, you know, what do you think? And you're just like, shh. You know, you accidentally, like, you know, step on his toe and sorry about that. No, I'm just kidding. But you know what I mean? Like the convenience of whoever happens to be there at the time that I ask the question. Okay? If I want to survey students in Stonewall Jackson High School and I say, 6th block, here we are, what do y'all think? Okay? That's convenience for me, right? But are we necessarily, this group in this AP class, representative of all the students at Stonewall Jackson High School? No. Okay? Because we're in an AP class, right? Not everybody is at the level that you are. You're smart. Okay? All right. The problem with convenient sampling is it's not representative. And it's used in the word, it's convenient, it's easy for the person doing the data collection, but it's not ever a good idea to do. Okay? Third, under coverage. Under coverage is almost always a problem. Okay? It can arise for a number of reasons. It's almost always a potential source of bias. Okay? What is it? Undercoverage is when your sample is not representative of the population in some way because some portion is not represented. This class only has sophomores and seniors. Who is not represented in this class? Freshmen and juniors. Is there any juniors? Because I have one junior in my other class, but I think we're all sophomores and seniors, right? So this class would suffer, if I asked you, would suffer from undercoverage because you're missing some parts of the population, okay? So that's an example. It's where some portion of the population is not represented, okay? It's not part of the sample. Undercoverage is almost always around. You have to be careful for that undercoverage. You don't want it to be a big problem. Okay? Now the next couple are very similar word-wise, so we have to be careful. I'll wait just a second until you guys ready? Again, these notes will be online if you need to go back. And I actually would recommend that. I'm going to recommend that you make note cards. You put the name on one and you turn it over and write the definition. So that you might want to go through these notes online to make sure you didn't miss anything when you do that, okay? The next one is called non-response bias. Non-response bias. This is number 4. Is that right? Bias type 4. It's different than the first one. Wasn't the first one voluntary response bias? What was voluntary response bias? People who have strong opinions are the ones that volunteer their answers. I volunteer that we're going to go see this movie because it's what I want. Okay? Non-response bias is different. Non-response bias is that a group of people don't answer the survey. Okay? And we know that no survey really is going to guarantee that everybody is going to respond. The problem is that the people who don't respond are going to be different in some way than those that do. So for example, I want to ask the senior class, I want to survey the senior class and ask them what their class gift is going to be. You give a class gift to the school. Okay? And so based on some of your faces, I don't think you knew you had to do that. But Ms. Mackert's in the market for Alexis, okay? So Alexis, so as in like y'all need to get your act together, okay? No, I'm totally playing. No, there actually is a class gift. The one of the previous years, the seniors gave that sign out front, the electronic sign. That was a class gift for the school. There's various that electric sign out front. They raise money. Yeah, the fundraisers are for part of that. Part of it's for like your trip, and there's lots of different things. So the class gift is something also. Okay. But how would my survey suffer from non-response bias? Well, let's say that the seniors that didn't know we had to give a class gift are like, I ain't answering that. Forget you. You're crazy, lady. Lexus, I don't care. Bye. I'm not answering that. So why would that be a non-response bias? Because the people that didn't answer the survey, their answer is going to differ in some way, some shape or form than the people that did answer it, right? So that's called non-response bias. When people that don't answer the survey, their answer, they choose not to answer for a reason. There's a reason why they don't. And their answers are going to differ from some way from the people that do. Okay? The last one is called response bias. Gosh, do they all have to sound alike, Ms. Mackert? Voluntary response bias, non-response bias, and now we have just regular old response bias. They sound alike, but they're all different. That's why I think note cards is going to be important here. Put the word on the front, put the definition on the back. Response bias is when the wording of the question influences the answer. I think the class gift should be Alexis for Mrs. Mackert. Don't you, Corinne? Wouldn't that be, that would be a response bias question, right? It's response bias because I am purposely wording my question in such a way that I'm influencing your answer. So you want to make sure how you word your question is important. And trust me, I have no clue what that means and why I typed it. I must have been, I don't know, combing your hair, what, I don't know. Sorry, ignore that. Okay? But response bias is when you're influencing, the wording of the question's influencing them. Okay? It's a type of bias. Yeah, please don't write that down. That makes no sense to me. I was distracted, I think, yesterday. So, well, you know what it is. Okay, fine. Right. Anyway, so you have a total of 6 ways of data collection, correct? You have 6 ways to collect data. And you have 5 sources of bias. Do you agree? Okay? So you have 11 new vocabulary words, but you also have words like sampling frame. You have words like population. You have words like, target sample. You have those symbols. Remember in the very beginning where we talked about the different symbols for statistic versus parameter? So we have done a lot of vocabulary today. I strongly encourage you to make some note cards. Now, I rarely say that in math, okay, because it's not a math thing to do. But because this particular unit is so vocabulary intensive, it would be a good idea to practice really understanding what these words mean, especially because there's so many that sound alike. Voluntary response bias, non-response bias, response bias, right? So one thing I'm going to ask you to do for homework is to do note cards. And they're not required, but it's a good idea. What is required is you do have some math homework problems on Math Excel. But guess what I learned how to do? I learned how to make the homework assignment smaller, okay? Because I think last time I assigned every problem, I didn't mean to do that. I'm learning, okay? So I think you only have a few problems. And these aren't like full simulations where they take forever. These are just vocabulary types of questions. So you should not spend more than 30 minutes on this assignment, okay? It should not take you that long. But this is going to be your homework. And I only see you once next week. I'm sad. It's only Thursday. I know April's like having a party back there, but she's like, yeah, only one time. Turn up. I hate this class. But anyway, by next Thursday, so you have time, okay? All right.